Mercury, often just a speck compared to behemoths like Mars or Jupiter, now hides urgent secrets beneath its surface. Scientists using powerful telescopes have stumbled upon these secrets. They are seeing something move that they've never observed anywhere else. These revelations could lead to crucial missions to uncover a terrifying truth about our universe. We are not alone. Let's reveal the dark shadow that Mercury has kept under wraps. This small, quick planet travels around the Sun faster than any other in our solar system, completing its orbit in just 88 Earth days. Historically, our understanding of Mercury was limited. Early astronomers had little more than basic telescopes to study it, and the planet's small size and rapid orbit made it a difficult subject to pin down. It wasn't until space exploration advanced significantly that scientists began to get a clear picture of Mercury. NASA's missions in the 20th century provided the first detailed images, revealing a landscape marked by craters. These images were just the beginning. Recently, enhanced data from space telescopes have suggested that there may be unusual features beneath Mercury's surface, prompting a flurry of academic interest. This interest has sparked both excitement and a fair bit of skepticism within the scientific community. Some researchers, buoyed by the new data, speculate about groundbreaking findings on Mercury, possibly relating to its geological features or other aspects that were previously unknown. Discussions have begun about more ambitious projects to study Mercury further. These plans aim to explore the planet in greater detail, potentially uncovering new information that could reshape our understanding of the smallest planet in our solar system. There is a sense of anticipation but also a need for caution, as these plans could lead to more invasive studies that might disrupt the planet's natural state. Amid this renewed focus, it's important to remember the broader context. Every planet in our solar system, including Mercury, has its own unique traits and history, which can provide valuable insights into cosmic processes such as planetary formation and the effects of solar proximity. As scientists propose more in-depth explorations of Mercury, they must balance their enthusiasm for discovery with consideration for the long-term implications of their research. The idea of uncovering new data is exciting, but it's crucial to proceed in a way that respects the inherent value of Mercury's environment. Studying Mercury turns out to be a rather tricky business, akin to trying to take a clear photograph while staring into a bright spotlight. Despite years of careful planning and advanced technology, scientists find themselves stymied by Mercury's proximity to the Sun. The Sun's intense light and heat not only make it hard to see the planet, but also pose a real risk of damaging sensitive equipment like telescopes. Consequently, astronomers can only look at Mercury in short bursts to avoid harming their instruments. Even the powerful James Webb Telescope has to steer clear of pointing too closely to Mercury for fear of sun-related damage. The hurdles don't stop at visibility issues. Sending a probe to Mercury is almost like sending it on a kamikaze mission. Any spacecraft that ventures near needs to be heavily armored against the brutal temperatures and the strong pull of the Sun's gravity, or it risks being destroyed. This makes missions to Mercury rare and brief compared to other planetary explorations, which might involve more extended stays. Mercury zips around the Sun at a velocity of 30 kilometers per second, making it the fastest orbiting planet in our solar system. This incredible speed complicates tracking and studying Mercury and presents daunting challenges for any mission that aims to land on or orbit closely around the planet. Only 2 missions have bravely targeted Mercury so far: NASA's Mariner 10, launched in 1973, and Messenger, which followed about 31 years later in 2004. These missions represent our main sources of first-hand information about the planet. Mariner 10 was equipped with advanced tools like 2 telescopes, spectrometers, a magnetometer, and a plasma analyzer, essentially making it a mobile science lab tasked with gathering as much information as possible from its quick visits to Mercury. The probe cleverly used Venus's gravitational pull to alter its path towards Mercury, allowing for a series of flybys that revealed the planet's surface for the first time to us Earthlings. The images returned by Mariner 10 unveiled a landscape riddled with craters and strange ridges, much like those found on our moon. This revealed that Mercury had a rough and heavily cratered exterior, along with a surprisingly strong magnetic field and a larger core than expected, challenging what scientists had previously assumed about its composition. During its second flyby in 1974, Mariner 10 captured views of Mercury's southern polar region, offering new vantage points and data on this difficult-to-study planet. The mission concluded with its final flyby in March of the next year, which provided yet more data but still left scientists wanting more comprehensive information, a desire complicated by the technical and environmental challenges of studying Mercury. To date, most of what we know about Mercury comes from those 2,700 images and scattered instrumental readings from these missions. Impressive, given the circumstances, but also a clear indication of how challenging space exploration can be. Every piece of data from Mercury is hard-won, serving as a small triumph over the vast and inhospitable conditions of our solar system. It highlights how our pursuit of knowledge about our planetary neighbors is often constrained by the realities of technology and the harsh environment of space. Thus, studying Mercury serves not just to quench our thirst for knowledge, but also as a reminder of the inherent difficulties of probing the cosmos. Each new finding is a step forward, yet it underscores the slow and laborious nature of uncovering the complexities of planets like Mercury. Next, we explore what happened after Mariner 10 and how its legacy led to new missions exploring the enigmatic terrain. When the Mariner 10 spacecraft ran out of gas in 1975, its mission ended, leaving it to drift silently in space. This marked the end of an era but also set the stage for its successor, NASA's Messenger, which took to the skies 30 years later. Unlike Mariner 10, which merely flew by, Messenger had a more ambitious goal. It was to enter into orbit around Mercury. This mission was designed to do much more than take pictures. It aimed to dive deep into understanding Mercury's atmosphere, its chemical makeup, and its physical features. Armed with the latest scientific equipment, Messenger was tasked with uncovering the detailed characteristics of Mercury. NASA's goal was clear: to gather a wealth of data that would offer insights far beyond the superficial layers of the planet. This probe was equipped to explore every aspect of Mercury, from its magnetic field to the geological and physical structure of its core. The mission was not just about capturing images. It was about comprehensively mapping and understanding Mercury. During its mission, Messenger made 3 crucial orbits around Mercury and took an impressive 200,000 photographs. These were not just ordinary images. They captured detailed views of Mercury, including areas never seen before during previous missions. The data revealed intriguing details. For instance, there were unusually high levels of calcium and magnesium on Mercury's darker side. This discovery likely raised questions about what processes contribute to such concentrations. Additionally, the planet's magnetic field was found to be unusually strong in the northern areas, which was unusual compared to other planets. As NASA analyzed the data, it became clear that Mercury's unique magnetic field was due to its internal structure and how it had formed. On most planets, like Earth, magnetic fields are generated by the movement of liquid iron in the core as the planet rotates. This liquid iron moves and generates electrical currents, which in turn create a magnetic field. However, Mercury's internal structure is different, leading to different magnetic behavior. The findings from the Messenger mission are significant because they offer a deeper understanding of Mercury. This is not just about gathering data for the sake of it. This knowledge helps scientists understand how planets form and behave. It challenges previous assumptions and provides new insights that could be applicable to other celestial bodies. This narrative of Mercury's exploration is a story of human curiosity and technological advancement. The journey from Mariner 10 to Messenger shows our progress in space exploration technology and our deepening understanding of the solar system. Each piece of data Messenger sent back to Earth not only added to our knowledge of Mercury but also helped us see our own planet in a new light. By studying Mercury, we learn more about the universe and our place within it, highlighting how interconnected and complex the cosmos really is. As we continue to analyze and understand the information gathered by Messenger, we build on the legacy of past missions. Each discovery adds to a growing body of knowledge that informs future explorations. The story of Messenger and Mercury is a testament to the enduring human spirit to explore, understand, and constantly push the boundaries of what is known. HOA from the University of California, Los Angeles, discovered something unusual about Mercury that has puzzled many scientists. Usually, in planets like Earth, iron changes from liquid to solid at the innermost part of the core. However, on Mercury, this change happens at the outer boundary of the core, which was not expected. This finding challenges the way we thought terrestrial planets behaved and suggests that Mercury has a unique way of doing things. In explaining this phenomenon, HOA compared it to a snowstorm, where snow forms at every level of the cloud, not just the top or bottom. This means that on Mercury, iron might be forming solids throughout the fluid that surrounds the core, affecting the planet's magnetic field in unusual ways. This discovery has important implications for understanding how magnetic fields are created on different planets, as it shows that the same ingredients can produce very different results under different conditions. Further analysis, backed by data from NASA's Messenger mission, supports HOA's findings. It seems that despite having similar elements like sulfur and iron in their cores, Earth and Mercury behave very differently. This raises interesting questions about the ways magnetic fields can form on planets, suggesting that what we learned from Earth might not apply universally. But Mercury's unusual characteristics don't stop at its core. The surface of Mercury experiences extreme temperature variations that are baffling as well. During the day, temperatures can reach a boiling 430 degrees Celsius, and at night, they drop to a freezing 170 degrees Celsius below zero. These drastic changes are due to Mercury's almost non-existent atmosphere. Unlike Earth, which has a thick atmosphere that helps regulate temperature, Mercury has only a thin exosphere made up of atoms knocked off the surface by impacts from space rocks. This thin exosphere does very little to protect the planet from temperature extremes or to retain any heat. It's so insubstantial that it's barely there at all, contributing to the extreme conditions found on the planet's surface. This aspect of Mercury is another factor that sets it apart from Earth and challenges the assumptions we have about planetary atmospheres and their effects on surface conditions. Such insights into Mercury's conditions provide a clearer picture of just how diverse planets can be, even within our own solar system. Each planet operates according to its own set of rules, influenced by its unique composition and environmental conditions. The study of Mercury invites us to expand our understanding and consider that the behavior of other planets might also differ from Earth in significant ways. Considering all these points, we're reminded of the complexity of space and the planets within it. Mercury serves as a case study for the unexpected, teaching us that planetary science is full of surprises that defy our standard models. As we continue to explore and study other celestial bodies, we are likely to encounter more examples that challenge our existing knowledge and push the boundaries of what we know about the universe. Each new discovery adds depth to our understanding and prompts us to keep questioning and exploring the vast unknowns of space. With Messenger's journey over, we now dive into Mercury's extreme conditions and surprises. A year shorter than a day, Mercury attracts scientists mainly because it's extremely hot. This intense heat prevents any kind of stable atmosphere from forming, as gases likely evaporate into space before they can accumulate. Mercury doesn't have a protective atmospheric layer, resulting in one side facing extreme heat from direct sunlight while the opposite side remains dark and cold. What stands out about Mercury is its peculiar day and year lengths. One full rotation of Mercury on its axis, which counts as a day, takes 176 Earth days. Meanwhile, a Mercurian year, the time it takes for the planet to orbit the Sun, is only 88 Earth days. This oddity leads to one side of the planet being scorched by the Sun for long periods, while the other side experiences an extended night. The idea that any form of typical Earth-like life could endure such conditions seems far-fetched. Despite this, the harsh environment of Mercury has sparked a lot of discussion and speculation among the scientific community. With its magnetic field and a composition that includes rocky terrain, Mercury shares some characteristics with Earth, although the similarities largely end there. The thought that Mercury could be a home to life challenges our understanding of biology, given its severe climate. Interestingly, Mercury's surface is peppered with many impact craters, much like our Moon. These craters are often the subject of speculation, as each new discovery on the planet's surface leads to more hypotheses about what might be possible there. This has led some to wonder about potential life forms that could exist, perhaps adapted to extreme conditions, living in the cooler, shadowed craters or utilizing minerals from the rocky soil. Theories about life on Mercury often require stretching the imagination to consider types of life that are vastly different from those on Earth. Could there be organisms that thrive on radiation, or life forms that exist without water? Such questions push the boundaries of current scientific thinking and delve into more speculative biology. This continuous interest in Mercury is not just about finding life, but also about understanding the limits of planetary environments where life might exist. As scientists continue to analyze Mercury's mysteries, the data from past missions like Messenger are still being processed, leading to new insights that may take years to fully understand. One area of intense interest is the planet's magnetic field, which remains a subject of debate among researchers. Unlike Earth's magnetic field, which is generated by the movement of liquid iron in its outer core, Mercury's magnetic field is thought to be driven by a solid inner core surrounded by a fluid outer layer. This unusual structure could explain why Mercury's field is weaker than Earth's but still surprisingly robust for a planet of its size. In addition to its magnetic anomalies, Mercury's extreme geological features continue to puzzle scientists. Despite its small size, the planet shows signs of tectonic activity. There are evidence of massive fault lines and ridges across its surface, suggesting that Mercury has undergone significant contraction as it cooled. These geological processes, though not as active as those on Earth, offer valuable clues about the evolution of rocky planets and their inner dynamics. Researchers are also exploring the possibility of volatile materials beneath Mercury's surface, which could have been trapped by its intense gravity and lack of atmosphere. Studying these volatile substances could provide insight into the conditions that existed in the early solar system, adding another layer to our understanding of planetary formation.